Going on to another case of getting the proof of a particular set operation, we are again looking at a relatively simple case, but there's an interesting difference in this particular case. The case is set A minus set B intersection set B uh, gives a null set. Now, uh, in a previous video, I told that you have to choose an arbitrary element on both or I mean on either sides of the equal sign and get a particular proof and then equate it by the by looking at the subsets. But in this particular case, we are dealing with a null set, and naturally, on one doubt that would arise is that how can we state that an element can be an arbitrary element can be uh, belonging to null set, as null set simply means that it contains no element. Now, there's no problem in going on for a particular case as if an arbitrary element exists, and that is exactly what we are going to do in this particular case. So, suppose X is an element belonging to phi. So we are doing it in such a manner. Taking X is an element of A minus B intersection B, which simply implies that X is an element of A minus B. That's a set operation of set A minus set B, and X is an element of B. Of course, as we are dealing with an intersection, it simply means that we are dealing with common elements. Now, in solving such cases, we are to get onto a contradiction, and it's a contradiction which gives the final proof. So we are looking at that particular step, and so we are separating out A minus B. That is, X is an element of A minus B means that as we all know, the set operation would give a set which contains elements of A but wouldn't contain elements of B. So that simply means that X is an element of A and X is not an element of B, and X is an element of B. Now that brings out what I call the key contradiction. The contradiction is that you have a sentence where an element is present in a particular set and it's also denied. So such a thing is not possible. So such a in a mathematical language, such a supposition is not possible. And we are not dealing with the Schrodinger's cat as in the case of physics. So anyway, if S is not an element of B, it simply means that a case of X being an element of B is not possible, which simply means that you ought to be dealing with a null set. So that leads to the final conclusion that set A minus set B intersection set B would be giving a null set. So thank you.